Okay, so this is our first passage. This is a chemistry physics passage. And like I had said before, that usually I like to just go to the questions directly rather than reading through the passage first, because the passage often has excess information, right? And so just for the chemistry physics section, I recommend this. So let's try this and see how it goes. So question 1. Which of the following gives the difference in pressure between the surface and at dive depth D? So right away, this, and if you're just looking at the answer choices, these are like a relationship of variables, right? This is an equation, basically, right? They're saying which of the following gives the difference in pressure, which is aka delta P, right? Delta P between the surface and a dive depth D, right? So this is not, do you guys think that we need to look at the passage, or can we solve this without looking at the passage in this case? Like, just in general, what do you think?
I think maybe we could just use the choices.
I think so too, yeah, because this is, we are familiar with the, well, we should be familiar with these things like density, G, gravity, D, depth they gave us, right? So these are things that are like known things that we should be able to not have to like go digging in the passage for, right? This is something it seems like they're asking us to figure out. So now, so good. So right now we know we don't need to look at the passage. Let's look at these answer choices. What stands out to you about these answer choices? Like a simple thing, what stands out to you?
They all have PG and everything else is different.
Exactly. Yep.
Yeah.
Yeah. Maria says similar variables. Yep. I'm sure you guys are referring to the same thing. They all have PG, right? That means we don't have to waste time thinking about PG. All we're evaluating here is the impact of D on this equation, right? So now now let's think a little critically, right? So let me annotate. So if we are reviewing D, right? We're trying to find out the difference in pressure, right? So these variables are going to equal pressure, basically, right? What do you think, if dive depth D increases, what effect will it have on pressure?
I think pressure decreases, or I
Give
could be wrong.
me 1 second. 1 second, sorry. The phone is in my room, and I usually put it outside before we do this, but I forgot this time. Sorry, what did you say? So wait, what did I say?
I think you were saying what happens to pressure if depth D increases.
Right, yes. So if we and what did you think?
I think pressure decreases if the depth is increasing.
Okay, so let's try to make up an example, right? What's something that goes underwater? Anything that goes underwater. A submarine, sure, right? A submarine, right? So I'm going to attempt to draw a crappy looking submarine. Here's my little submarine, right? And whoop. All right. And this submarine, right? Let's say it's at the surface of the water right now. Here right now, if this goes down, right? What prevents it from going all the way down? Like, why can submarines go all the way to the bottom of the surface? Density, right? Yeah, density of water, right? So let me just like draw like a few couple of like water flecks, right? When something is in water, right, the pressure of like all these little water molecules acts on it, right? And so the the question, so when we think about pressure, right, we're thinking about, will it increase or decrease when we go down in the water, right? And this is something like, there's a lot of things in physics where you're gonna like, it's a very basic question. Will pressure increase or decrease, right? And it may be obvious if you know it, but you can also have the wrong understanding of something, because like physics is not always intuitive, right? In this case, the more something goes down, the more the pressure builds up. Why? Because the weight of the water on top of the thing is increasing. The weight of the water. So this is like a very simple relationship that you now have in your head. And if you didn't know it before, you now know that, oh, I had a misconception. That's something that you can correct with a card, with a flashcard or something, right? Basically, you would now know, okay, very simply, as we go, as depth increases, pressure increases. And so these very simple, if X increases, then Y increase or decreases. These relationships are so important. They're like almost all of, actually like all, like the more like everything is like this, because even once you hit like, when you're like a doctor, like you're going to be talking about like, if this biomarker increases, then it means decreased function of this organ or something like that, right? These relationships are throughout. And in this case with variables, we're again talking about relationships. So if you didn't know it, you could go look it up, right? You could go, well, I'm not going to do that now because it will give away the answer. But basically, and the good thing is you want to make a guess at what you think it is, what you think this relationship is. Because if you're wrong, it's going to help you correct that. And if you're right, it's going to help you answer the question. Does that make sense so far? So right now, the relationship is that pressure increases as depth increases, because the weight of the amount of water on top of you is more. You can think of it that way, right? So linking it back to the actual question, right? Which of these mathematically represents, as depth increases, pressure increases? Which of these choices represents that? As depth increases, pressure increases. Okay, so let's start with which of these choices does not represent that? Which of these choices does not say that as density
B.
increases? Which one?
B does not say that.
Right, obviously, because there's no depth
Density.
here. There's no
Or
depth
yeah.
here, right? Yeah. So obviously it's not B because it doesn't make a comment on depth at all, right? Now, let's say, so for example, and I would do this very often. If I was confused about like the letters, right? I would just plug in numbers and try to understand, right? So PGD is equal to something, right? And let's start with like, let's say that D is 1, right? If I put 1 in here, then I'll get 1 PG. What happens if I increase D? What will I get? Instead of 1, if D is 2, what will this equal to? So if it was 1, we get 1 PG, right? For the answer choice A, if D was 1, then we would get 1 P. Wait, is this making sense? Hold on, wait. I might be doing this dumbly. PGD, if D equals 1, then the pressure equals PG1. What I just wrote, does that make sense?
Yeah.
Okay, so what if D equals 2?
PG2.
Then PG2. So in that equation, did pressure increase or decrease?
Increased.
Increased, right? So in choice A, in choice A, we see that as D increases, P increases, right? Or they're directly proportional, right? So this was the relationship that we were looking for. because we had said from our concept knowledge, as D increases, P should increase. So now we see, and this is another thing that you can, this is just a structural pattern, I guess you could say. If a variable on this side, so in this case, let's say ABC is equal to EFG, right? Here is C and here is E, right? They are both, they're not being divided by anything. They're standalone. So what that means is that if C increases, then E will increase, or F will increase, or G will increase, right? Because they're on the same level. That I know that this is not the mathematically correct way to explain it, but I'm just explaining it conceptually. They're on the same level. What if it's AB divided by C? What happens if I increase C now? If I increase C, what happens to E or F or to G?
So I don't know about individually, but the total value of EFG would go down.
Correct, yes. You're right, like technically, like it should be the total value, but one of these variables, we're not sure which one of these variables must go down for the total thing to go down, right? It might not be all of them going down, but at least one of them is going down. So the point is that the relationship is that if it's X equals Y, then we know it's a direct relationship. If you increase X, you increase Y. But if it's 1 over X equals Y, then it's the opposite. It's indirect. If you increase X, then Y decreases. So we saw that, oh wait, did I get rid of my whole, no, okay, I had it. So I'm just gonna leave this here. So we saw that in choice A, as D increases, P increases. So this is a possibility, right? This is possible. What other choice has a direct relationship where as D increases, P will increase? One and four, right. Can you talk about why the fourth one is a direct relationship?
So the fourth one is the same as the first one, but it like D is just squared, so it'll just be higher.
It'll just be higher, exactly, yes. So, right, these are both on the same level, right? And so what about C? C is what we just talked about, right? If it's 1 over, right? So, and again, if it's confusing, let's just plug in numbers, right? Let's say, okay, what if P, as in pressure, is equal to density G divided by D, right? Now let's say that D is 1, then P is equal to PG divided by 1, right? But if D is 2, if D increases, then P equals PG divided by 2. Which of these is bigger, PG divided by 1 or PG divided by 2?
Divided by 1?
Divided by 1, right? Because this is 100% of the value, and this is only 50% of the value, right? So we see, so this is referring to choice C. We can see that as D increases, P decreases. By P, I mean pressure, right? So in this case, this is not C is not the relationship we're looking for, because we were saying that as D increases, P should increase, right? So on that basis, we can eliminate C as well. Now we have to make a decision between PGD and PGD squared, right? How do you know what PG is? Are those two different variables? So how do you know what okay, let me think about that. How do you know what it is? So I guess you can look in the thing and it will tell you what they are, right? But these are also pretty common variables that you would probably already be familiar with. Like it is given to you here because they will they will always give you stuff that like is kind of, yes, it is from an equation, right? And it's also like G is gravity and P, this is not actually P, this is called rho. this like slanted P is called rho, and it's the symbol for density. So these are things that you would probably already be familiar with, but they would give it to you here as well, because that's not actually what they're testing at all, right? Because you see every choice has the rho and the G. So they don't care if they give you what it is, because that is just a stepping stone to test you on, do you know the effect of depth on pressure, right? So, and like Maria said, this is from an equation. So now the part where we have to determine A versus D, right? If you know the equation already, then this is easy, because this is just an equation. This is just the equation for pressure, for hydrostatic pressure, for water pressure. So if you knew the equation already, you would easily be able to say what the answer is. If you didn't know what the equation was, it would be a harder time, because what you would have to do is, what did I teach you guys about like solving these problems? The thing that I taught you was it's all about the units. It's all about the units. So if you knew the units for density, and you knew the units for gravity, and you knew the units for depth, then you could combine them all together and see, does this give me the units for pressure? And what is pressure? Pressure is force over area. So technically, you could do all of that. Of course, that is an extremely long and laborious process, and it's much easier to just memorize the equation, unfortunately. So does anybody know what the equation for hydrostatic pressure is? It is from an equation. It's one of these two. It is, which one? PGH, yes, PGH. Or in this case, they put it as D, where depth D was this height here. They called it depth in this case, but it's the same thing as height. So in this case, this is the correct choice. And so for eliminating this one, you could do it, like I said, by going through the equation, by going through the units rather, but that would be quite a lot of time spent, when you could my philosophy for studying was like, if I can prepare for it beforehand, then I don't want to do it on the test, right? So it's like, I can save myself time on the test going through all the units if I memorize the equation beforehand. So that would have helped, but of course I'm showing you guys how to think through it critically, because that is going to help you. Like we noticed what was in common, we got rid of the ones that weren't matching our relationship, and then we determine what our answer choice is. Anybody have any questions on this question? Okay, so I am going to clear everything and move on to the next choice. Oh, I have to switch the mouse. Right. Okay. Which of the following symptoms could be a consequence of Pascal's principle? So right away, obviously they hit us with Pascal's principle, right? And this is like, okay, if you don't know this, then what are you supposed to do? So now what we can do is look at the passage and see if there's anything about Pascal's principle to help us, right? So we can read through this. And I would usually like skim these, and I wouldn't read it too far. Like I would be hunting for the word Pascal principle or something similar to that if I was doing this right now. So in addition to decompression sickness, divers must remain wary, chemical forces act on them. Common class of injuries known as barotraumas. So they did say something about, or rather, no, sorry, the first answer choice is barotrauma, so never mind. Barotrauma occur due to mechanical forces occurring within the body due to pressure gradients that occur inside and outside the body, depending on the rate, fluid pressure, blah, blah. Barotrauma, particularly troubling. Diver. So unfortunately, I don't see anything about Pascal's principle here, right? So this is effectively like a discrete that's saying, hey, do you know what Pascal's principle is, right? What if we don't know what Pascal's principle is? Like, if it obviously on the test, you're kind of in trouble. But when we're studying, like, what if we don't know what Pascal's principle is, right? Well, it's time to, consult your resources and learn what it is if you don't know what it is. So what are my resources, right? The resources that I use when I'm doing practice passages like this is this the science outline that I had linked you guys before, which I can just link again. Do 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 do. And now as you have it, the my Anki deck, right? So we could go here and we could look for Pascal, and we've got my fluid properties card, and maybe there will be something about Pascal here, and we see Pascal's law. Force 1 over area is equal to force 2 over area 2, right? Okay, maybe that doesn't help me, right? Let's keep looking and find out something about Pascal. So I just controlled F for Pascal. Let's click on this and like read a little bit about this and see what the deal is. Pascal's principle applies to static fluids and takes advantage of the height dependency of pressure in static fluids. Pascal's principle can be used to exploit pressure of a static liquid as a measure of energy per unit volume to perform work in applications such as hydraulic presses. Qualitatively, Pascal's principle states that pressure is transmitted undiminished in an enclosed static liquid. Qualitatively, Pascal's law is derived from the expression for determining the pressure at a given height or depth within a fluid and is defined by Pascal's principle. And then this is given as the principle. And all of this. So the thing is this is like an equation, right? But the question seems more conceptual because they're not asking really about equations or anything, right? So let's try and think this through. Which of the following symptoms could be a consequence of Pascal's principle? A. Barotrauma to a blood vessel distance from the part of the body that was exposed to pressure. So what was barotrauma? A common class of injuries, known as barotraumas, occur due to mechanical forces occurring within the body due to pressure gradients that occur inside and outside the body. So which of the following symptoms could be a consequence of Pascal's principle? Interesting. Barotrauma. So in this case, I rather than evaluate one by one, like I would read through all the choices first and see like what direction I want to head in. Barotrauma to a blood vessel distant from the part of the body that was exposed to pressure, gradual damage to muscle groups due to delayed diffusion of pressure into tissue, overstretching of tendons and ligaments during resurfacing, or sudden cramping in muscle groups in the extremities and torso. So going off of the passage, right? They did say barotrauma can occur at depths as low as 20 meters. And so they didn't say anything about resurfacing, right? So this immediately makes me think like, maybe this choice is incorrect. And this is what I would do during the test. I would like strike, so you can strike something out with Alt and S, or you can highlight with Alt and H. And that will help us like eliminate choices. I'm thinking it's A. Barotrauma to a blood vessel distant from that part of the body that was exposed to pressure. Sure, why do you guys think it's A?
So,
Okay.
at least from, maybe this is not the correct way to come to this conclusion, but just based on the answer choices and then even the passage and talking about barotraumas, but also like the little bit that I know about Pascal, I know has something to do with pressure and something to do with fluid, and I'm like trying to pull any of that out from the rest of the choices, and I'm like, okay, blood. I don't know. So that just like kind of like brought me to A as like best guess.
Yeah, that's great. No, that's a very, very good like how you're thinking of it. Maria, what did you want to say something?
Yeah, I was gonna work you guys through like the way my logic worked for this one. So I didn't know what Pascal's principle was from the start, but I knew that like pressure equals force over area, and that kind of unlocked the principle. Like I remembered it from that. And then I remember in the passage it says that like it mentioned very subtly that sometimes they get troubling injuries in
Mhm.
the second paragraph, if like different parts of the bodysuit are like pressurized, uneven, like one part isn't pressurized well versus the other. And
Right, you're
like,
talking about this part, right?
yeah, exactly. Yeah.
Mhm.
So it was like, okay, that's like a random part in there. But then choice A is the only one that relates back to like different body parts being exposed to pressure and of how it would be affected. And because Pascal's principle also forms a relationship with like force over area is equal to force over area, I thought, okay, that's the only other one that's trying to make like relationship with two different like pressures.
Excellent. Yeah.
Yeah.
Yeah, excellent. Great. You guys both pulled like little bits from everywhere and like synthesize it into an answer, right? And it seems like A is the answer because this is talking about delayed diffusion of pressure. We don't get any of this from neither the passage nor our like little bit of understanding of Pascal's principle, right? Like as you mentioned, force over area. What does that have to do with diffusion, right? And this D one, sudden cramping, doesn't mention pressure at all or area at all, right? So and that kind of brings us to A. And if we take a look at the solution, it is A, right? Barotrauma arises due to differences in pressure in different parts. Pascal's principle states that pressure is transmitted equally through a fluid in a sealed vessel. When pressure is suddenly applied to the surface of the body, blood vessels can propagate that pressure to distant tissues via this effect. Barotrauma in distant tissues may be a consequence of Pascal's principle. So this is a very good example of the kinds of physics concepts that you will see applied on the MCAT, because you have probably learned physics in the concepts of just physics, right? They just give you Pascal's principle as force over area. That's what it is. But the MCAT will constantly try to apply it to, what about this biological thing? Or what about this interesting like scenario where you can where you haven't seen it before, but you can technically think about it and like from the information you've been given, you're like, okay, I can see why this would be the answer. And that's exactly what you guys just did there. So like pat yourself on the back. That's basically how you're supposed to go through this problem. Because I'm sure you guys have not seen anything about, probably haven't learned about barotrauma directly, but with what you have, you can get it. So good job. Any questions about this one? Okay, let's do this one. What is the buoyant force acting on the ascending diver's body, mass m and volume v, where g is the standard acceleration due to gravity? So this is again a situation of you can work it out or you can just memorize the equation. And I would highly recommend memorizing like everything related to like pressure and fluids, because it comes up constantly. It comes up with like blood, and it comes up with like all sorts of like fluid related stuff shows up. So did anybody memorize the buoyant force formula yet? And you'll notice it's very similar to another formula that we just talked about. Right? It's very similar. Previously we had talked about the hydrostatic pressure, right? Hydrostatic pressure was density, gravity, and H, right? And this one is density, gravity, and volume, right? And notice that, it's the difference between force and and pressure, right? And you can actually, if you break down the units, you can see the difference, right? If we do this right now, you'll be able to, like, again, like you could do this on the exam and it would cost you a little bit of time, but it's also like cool to see that you can do it, right? So if we know that pressure is equal to density, G, and H, right? And we know that, well, we don't know, we may not know right now, but I'm just showing you buoyant force is equal to density, gravity, and volume, right? So what's the difference between these two equations in terms of units? Well, H is just a regular, H is meters, right? And what is volume? Anybody know what volume is? Volume? Meters? How many meters? How do you get the area of a cube? Volume of a cube? Anybody remember? Cube. I'm giving you the hint. Cube. Meters cubed. Yes. Meters cubed, right? Volume cubed. So volume is equal to meters cubed, right? And so H is meters. So what is the difference between these two equations, right? So what is the difference? This is actually a very important question. What is the difference between these two equations in terms of units? What do you what was added to this formula?
The cube.
Almost. Yes, sort of the cubed, but not. Let me write it out and you might see it better. Volume is equal to meters times meters times meters. What was added to the second equation? One is meter and one is cubic meters, yes. But how many, here's the question. How many meters was added to the second equation?
2 times.
Two
amount.
times. Yes, meters was added twice. So it's not that meters cubed was added, it's that meters squared or was multiplied technically, right? It was multiplied by meters squared. Does anybody remember what pressure is? Pressure equals force over area. Anybody remember what area is? Do you guys see where I'm going? Yes, no?
Yeah, like they're all like related in a way. The
Okay, let me.
dimensions of them.
I
Is that
see.
what you're talking about?
So what I'm saying is what I'm trying to explain is how do we go from pressure to buoyant force? If pressure is PGH, right? And pressure is equal to force over area, which is force over meters squared, right? And the buoyant force is force.
Are you asking us to square the value of pressure?
No, I'm saying that we can multiply the wait, hold on. What am I saying? Pressure equals PGH equals meters, and this is this. Yeah. Okay. Now I know what I'm saying. Yeah. Okay. So if P equals force over area, then if you multiply the P times the area, you get the force, right? And if you multiply the P, so here's the P, right? If you multiply PGH times meters squared, you get the force, which is PGV. And so the reason this works is because the only difference between PGH and PGV is a factor of meters squared. In other words, it's the area. So if we start here if we start very simply with the fact that pressure equals force over area, then we know that force is equal to pressure times area, right? All I did was multiply each side by area. And I know that area is just meters squared. So my force is PGV is equal to PGH times meters squared. Does this make sense? Because PGV, I'm going to write V out as meters. I'm going to write V out as meters times meters times meters. And I'm, excuse me. equal to PG, and the H is 1 meter times meters squared. Okay. Does that make sense, or should I explain it again? Yes, exactly. Units help a lot with figuring out the equation. The problem is that it takes time, right? So if you're forced to do it on the exam, you can do it and it will help you get to the choice. But if you do it now, like what we're doing now, it will help you solidify those relationships. So you can see now, oh, how does pressure and buoyant force relate? It's simply a matter of multiply the pressure times the area and you get the force. How do I know that? Because I can literally multiply by the meter squared and I can see that that's what happens. So I'm trying to figure out if I can explain it in a better way, because this looks very messy to me. Does it make sense does it make sense what I'm trying to explain? Okay. Lamisha, you got it, or should I try a different way?
No, I think I do get it.
Okay, great. So basically my point was just like, hey, units are really good, and if you're confused about like how things relate, break them down to all the way to like their base units, and then you can compare. But notice that I didn't break down like the P and the G because I don't need to. They're in both of them, right? They are in both of these equations, so they would just cancel out anyway, right? So you wouldn't even need to bother with them. But basically, yeah, that was the point. That was the point. All right. So, and we just spent like 10 minutes on that, or you could just memorize that this is the buoyant force and get this correct. So pick your poison, basically. Yeah. Yes. Basically, yeah. But I mean, it's good to obviously it's good to understand how things relate. How things relate is very important. Okay. Which of the 4 diving procedures would be most effective in preventing barotrauma? Now, obviously, we need to read the passage, right? But notice that we managed to get through like 2.5 questions without really reading the passage deeply. And there's a lot of passages where like you can get away with that. And in this case, like we only need to focus on like the diving procedures, right? So let's try to understand what this is all about. So which of the 4 diving procedures would be most effective in preventing barotrauma? So in addition to decompression, well, first of all, I want to hone in on like what they're talking about with diving procedures, right? I want to understand what they're talking about. Okay, here. A diver has devised 4 different options for a dive to a depth of 40 meters over 90 minutes. For safety, she plans to maintain a fixed positive buoyancy and manually swim against their buoyancy in order to travel deeper. Her candidate diving procedures are illustrated in a depth versus time graph in figure 1. So all of that, if you didn't understand, it doesn't matter, because basically all you need to understand is the graph, right? The graph is showing us the 4 different options. Option A is, so all of them we notice is showing that over time the depth is decreasing, right? Over time the depth is decreasing in all of these. The only question is the path that they took, right? The path that they took to get to this bottom right point. So the question is, which of these 4 diving procedures would most effective in preventing barotrauma? I don't know anything about barotrauma. I didn't learn about barotrauma. I need to read the passage and figure out what the hell barotrauma is. So let's start. In addition to decompression sickness, deep sea divers must remain wary of injuries arising purely from mechanical forces that act on them as they ascend or descend significant depths. A common class of injuries known as barotraumas occur due to mechanical forces occurring within the body due to pressure gradients that occur inside and outside the body. Depending on the rate at which a diver ascends or descends, the fluid pressure inside their ears and other soft tissues may not have time to equilibrate with the external pressure, resulting in a difference in pressure that can cause mechanical strain in sensitive tissues. Okay. Right in this passage is a very, very big hint at this answer. Did anybody catch the hint? Think about what a graph tells you. Like what is it? What values can you get out of a graph? Actually, that might be a little too vague. Basically, what is the difference in these various paths, right? Like forgetting the passage, right? Like if I asked you to describe, hey, what is different between A and D? What might you say? Just evaluating it as a graph.
I don't know. Are they the inverse of each other?
That is true. I mean, they're sort of like the mirror flip of each other. That's true.
Yeah.
What is like in terms of like mathematical terms, like what is different, like say comparing C to D? We know C is like a very particular kind of line, right? Like it's a specific style of man, I don't even know what the correct word is for the category or whatever. Basically, I'm just trying to say that this is like a linear. Look good. The curve's linear, right? So this one is linear, and the other ones are not linear, right? What does it mean if something is linear? What is mathematically? What does linear mean?
So like always constant.
What's always constant? Something about this line is always constant. You're correct. What is that? Direct relationship. Yes. Okay. So you got yes, Maria got it. Slope. Slope is always constant. Correct. Did you guys see anything in this first part that now pops out to you? Given the word slope. What is the slope? I would not have thought of that I would not have thought that critically on the actual test. Don't worry. When you graphs are always going to be like in that vein, like comparing the slope, comparing the comparing how things change. So you will think of it critically on the actual test if you start doing it now, basically. But yes, so in this passage, does anybody notice anything that relates to slope? What is slope? What does slope tell us about a line? In fact, I'm pretty sure we can go, yes, x over y, right? Can I find something about slope here? No, it's kind of like woefully bad about math. But yes, x over y, right? And so that x over y is static or it's changing? In this case, it's static, right? Because it's a linear thing, right? It's static, right? What did they talk about? So I will just say the hint here. A common cause of injuries, et cetera, within the body due to pressure gradients that occur. Depending on the rate at which a diver ascends or descends, the fluid pressure inside their ears and other soft tissues, blah, blah, blah. The rate at which a diver ascends or descends. The rate at which the diver ascends or descends, notice that this is depth over time, right? So rate is the rate at which they descend is the slope of these curves, the slopes of these lines, because it's the rate is if you descend very quickly, right, then your line will be like something like this. Oh, I could just draw something. If you descend very quickly, your line will be something like this, right? And that will have a very, a steep slope, and the rate will be very fast. But if you do it very slowly, your line would be something like that, right? So the link here was the rate. And if you're like, oh, like, dude, how was I supposed to catch this, right? Like, this is so small in the whole passage. The thing is that as you read, as you like, you will get better at like understanding how to explain. You'll get better at understanding what to look for. That's what it is. You'll get better at understanding what to look for. Because we start with a graph, I'm thinking about, okay, what keywords exactly? I'm going to be thinking about like, okay, I'm going to look for something about slope. I'm going to look for something about rate. I'm going to look for something about change over time. I'm going to look for something about, I don't know. You get what I'm saying, right? You're going to be thinking about what is this question actually asking, right? What am I actually supposed to be thinking about? And in this case, it was the rate, right? And they're saying depending on the rate at which a diver ascends or descends, the fluid pressure inside the blah may not have time. So what does this tell us? This is again giving us a keyword into a relationship, right? So we're going to write out the relationship. Barotrauma increases as time what? As time increases or as time decreases? Read these lines carefully and think about this. And if this doesn't, whoop, I need to go here. And again, you have the graph to help you, right? Correct, as time decreases, right? Because they said if we don't have enough time, then we get injured, right? If we go down too steeply, right? If we think about the rate, right? If you don't have time, then you're going to be low on the x-axis. If you're low on the x-axis, then you don't have time, right? So correct, as time decreases. So now our question is, we have to actually go back, we actually have to answer the question, right? So which of the 4 diving procedures would be most effective in preventing barotrauma? Okay, so now, the way that we can answer this is, oh, why did I put this here? That right there. Okay, so we saw that depending on the rate at which a diver ascends or descends, the fluid pressure inside their ears may not have time. So the rate, right? So the slope, right? Of these choices, which has like the worst slopes, basically? And which of them this is hard for me to like put into words properly. But basically, like, obviously, man, I don't even know how to ask this question. Basically, what I'm saying is like, which of these has the worst slope, and which of these has like the least, steepness, I guess. Which of these has like the most steep slopes, and which of these has like the least steep slope? It's kind of hard to think about, but that's basically what I'm asking. And this kind of relates to like, I think they're called like tangent lines, right? Like, so if you take the tangent line here, right? Like this is a tangent line, right? And the tangent line here is like this, right? Is like this, right? And so overall, look at how steep the slope is here. Do you guys see that? Right here? And do you guys see how steep the slope is here? But this one doesn't have anything like that. This one is just straight throughout, right? So there's no patches of steepness. This is a site where barotrauma injury can happen because the rate of diving, down is so fast. It's happening over such little time, right? Whereas in this case, if we look at the same exact descent in the purple line, right? Look at how much time he takes instead. Way more time. Do you guys see? I should probably use a different color for the second one. Do purple. I'm drawing the descent for C, and we can see how much more time C takes on that section. So this is what they're asking you to compare. They're asking you, so we were linking, so we started from, so basically the logic chain that they asked you to take was barotrauma affect, how is barotrauma, so barotrauma affected by time, time affects rate, rate affects the diving procedure. Do you guys see like how we did 1, 2, 3? How we went through each one? First, we learned about barotrauma, and then we learned about, you know, the decreased time. And we also learned about the rate, the increased rate. So then we knew how time affects rate and how rate affects the diving procedure. So knowing all this, which of these 4 diving procedures is the most effective at preventing barotrauma? Meaning, so again, work backwards through the relationship. Prevent barotrauma means what kind of slope? A steep slope or a flat slope? And if we, again, we can work through it even more, right? Slope leads to rate, right? So do you want high rate or low rate? Exactly. So we want flat and we want low. So notice this, I would do this all the time. The way that I'm like linking concepts is the bread and butter of this exam. This is how you do everything. By linking things and asking, okay, this should give me what of this? This should, if I want, so I would even, instead of preventing, make it easy for your brain. Low barotrauma equals like high slope or low slope, right? Like obviously, like, you know, you can just use whatever words like make sense to you. So I would say like a low slope. And if it's a low slope, then it's a low rate. And now I have the logic chain that I need to answer this question, because I know which of these is the one that, which line experiences the lowest slope, which line experiences the least, you know, steep slopes. We saw that, correct, yes, C. We saw that we have a steep slope here in D. We have a steep slope here for A. We have some steep slopes right here. I mean, they're not as steep as the other ones, but, you know, they don't compare to C, because C is just a consistently, you know, smooth slope. So obviously that was a lot of, you know, explanation, but the simple truth of the matter is, no, how do I, okay, that's really annoying. The simple truth of the matter is this part, is this, making your relationship, because your relationships are everything. Your relationships help you answer the questions. Any questions about any of this? How we attack this, how we, you know, does it make sense? Like I know you're probably like hesitant about like, oh, will I be able to do this on the exam? The point is, like, I'm not giving you the, I'm not saying that you need to exactly do this on the exam. I'm saying that I'm teaching you how to identify the relationships so that you can do it on the exam.
Yeah. I have a question. So, with barotrauma, was it just? Is it all the time being in the water, or just when you're resurfacing?
It was not about resurfacing, because they were
Okay.
saying that oh, I've got all this crap on the screen now. They were saying barotrauma can occur at depths as low as 20 meters. So they were talking about like it can happen when you're below the water rather than resurfacing in the water. Well, they did say depending on the rate at which a diver ascends or descends. So it could be either.
Okay. Okay. Yeah.
It's a
Yeah.
pressure, yeah, it's a pressure difference. It's about the rate, right? It's about how fast do you go up or how fast do you go down, causing your barotrauma.
Okay.
Okay.
Yeah. Okay. I completely see why it would be C then.
Awesome. So then, and it should be C. Yes. So the danger of barotrauma comes from the rate of pressure change. Pressure changes linearly with depth, and so pressurization rate corresponds to the slope of the curves. This was it. Look. Okay, guys, look. This is so important. Look how they did the step by step, like we just did. We said rate of pressure corresponds to slope. Oh, I can't highlight this part, but I can draw. But this is so important. We talked about rate, and then we talked about slope, and then we talked about barotrauma. Do you guys see how this is exactly what we just did? What we just talked to, the relationship wise. I cleared it, but I had written it before. I'm sure you guys saw it. That is exactly the logical steps that they want you to take. And again, you're going to be able to see keywords because rate and slope is a keyword that you can now identify. Is a relationship that you can now identify. If you now come across a passage that asks you about rate and there's a graph, you can now know I'm supposed to look at the slope, right? And these kinds of like links is why I say, you need to do lots and lots of practice problems because you're going to be able to identify them for yourself when you like understand, oh, I was supposed to link this to this. Now I know I have to do that. Does that make sense? This logical chain is what I'm trying to teach you how to create, basically. Okay. All right. Any questions on, logic chain or this question or anything else before we go? I think there's one more question. Yeah, 4 out of 5. All right, we good? Let's go on. Whoops. Let's go on to the next choice. I mean, the next thing. All right. Which of the diving protocols requires the diver to do the most work? So again, this is, a relationship thing. Work. They're asking you about work, and this whole thing is about, pressure. They're asking about the protocols, right? So these are the protocols, right? Whoops. These are the protocols. A diver has devised 4 different options, diving procedures, and which of the diving protocols requires the diver to do the most work? Work. So work is did anybody take like thermodynamics or anything like that? I think I did like a bit of thermodynamics because I took like biophysical chemistry for some reason, but you avoided it. Yeah. Yeah. A little, I think there was a little bit in physics, but I don't actually remember the physics part. But basically, what is work essentially? Like at the most, work force over area, or are you saying or area? What do you mean by or? Force over area. No, isn't pressure force over area? I think we just talked about pressure equals force over area, right? And force time, I think work is force times area. Yes. And again, this is like another relationship thing where you can like put in pressure, and you can see like, oh, how does pressure wait, actually, this is what the question is asking you a little bit. Yeah, this is a little bit what the question is asking you about, like comparing pressure to work, right? So basically, we need to think about which of the diving protocols requires the diver to do the most work. So what do we think? Do we think that, so basically the only choices are they all require equal work, or they all require no work, or it's A and D, or it's B, the zigzag one. Which of the diving protocols requires the diver to do the most work? So work is like, Okay, there's two, okay, so there's two conflicting things. It's the same distance, yeah. It is the same distance, right? So it should probably be the same. Oh wait, no, isn't work force? Wait, why did I write force times area? Isn't work force times distance? Yeah, force times distance. Yeah, I think I was confused by the other thing. Work equals force times distance, right? So since it's the same, so okay, is it the same distance in this case? Is it the same distance? You think so? Why do you think so? Depth is in meters. Yeah, that's right. It's just meters, right? So it's distance. Exactly. So it is the same distance. But what about the fact that like they're slowing down and speeding up, right? Does that have any effect on work? It actually doesn't, right? Because it's just the force times the distance. Yeah, it doesn't have an effect on it. We can just clearly look at the equation and be like, you know, there's force and there's distance and that's it. So in this case, do they all, can we use the equation work equals P delta V for this? Ah, good question. Good question. And that's something I was thinking about. And I'm not sure because like if you think about that equation, then work is work path dependent or path independent? Heat work equals, I think it's independent, right? What is path dependent? Heat is path dependent and something else is path dependent. But if work, I don't like throwing it. Me neither. I don't know. Yeah, I don't. Can we use equation work equals P delta V for this? It's most definitely A if we just think about like gravitational potential energy and like how it relates to work. Should definitely be A. Yeah. With that formula you get A. How do you use that formula? Because I've totally forgotten. The work equals P delta V.
Yeah, because I think they go at all at the same pressure, right? And the volume is also the same since they're ending at the same time.
Mhm.
And the depth is also the same on the side. So if both variables are same for all four of them, then I would just assume that the work is the same as well then.
Right, because we can link the depth to the pressure
Yeah.
through PGH, right?
Yeah.
Right. Okay, I get where you're getting at. Yeah, basically. We don't have the numbers, but conceptually we can link it that way. Okay, yeah, that makes sense. Yes, so then technically since it's all the same pressure, then we would get all the same works. Yeah. Except it wouldn't be delta V here, it's just delta M, right? But interesting.
I'm not
I'll-
sure. I thought the formula was just in general like P with sorry, I thought the formula was just like work equals P delta V. So I just memorized it as that, but
No,
it
yeah,
probably
that is the
shouldn't be.
formula, right? But the delta V is change in volume, right? It's like
Yeah.
if it's a container is expanding. In this case, we're not expanding anything. We're just moving, you know, from one distance to another, not a
Right,
distance
yeah.
cubed. So I'm just speculating. Like I don't know why if that works or doesn't work or what that does. But yeah, interesting, interesting. But basically, I think everybody was able to understand why this is the way it is. Good. Oh man. My original plan was to spend half an hour on each one so we could do like 4 of them from each. And it's 6:10 right now. So we somehow spent an hour and 10 minutes on this. Yeah. So I think this was super formula heavy. Yeah, it was. I mean, it was also conceptual if you needed the concepts, but otherwise know your formulas. You don't want to go in without knowing your formulas. It's very sad if you study your formula and then you're like, oh shoot, what is this formula? It's not a good time. It happened to me. Okay. Anyways, let's take a quick break and I think we'll do cars next. Ah shoot, this is do you guys think this was like a little too slow or is it okay? Because like I'm not sure because I thought we could do 4, but maybe we can't. I don't know. Not slow? Okay. I think we'll okay, we'll do cars next and we'll see how it goes then. Let's take a quick like 4-minute break and we'll come back at like 6:15. Okay. We're back. Time to do some cars. So I think what I will do this time. Oh, wait, can you guys hear me?
Yes.
Okay, so I think what I will do this time is read through the passage and I'll show you guys how I like to highlight or just like the things that I take notice of or whatever. And maybe that will help you like be directed in your reading. Because I remember last time, like when I said like go ahead and read the passage, like a lot of people were saying like they fell asleep while reading the passage. So I will try to read it for you guys. Yes. Okay. So I'm gonna try to figure out. I'm gonna try to give some tips, just forgetting the questions, like just some tips on reading, right? Um, what helps? What helps me read? I like to think about like read it expressively. Like even if it's like boring as rocks, I try to pretend like it's the most interesting thing ever, and then like read it like very expressively, and then like pretend to care for some reason. I don't know. I think everybody finds a different way to power through, but I'm going to read this as if I were doing a test, but I'll read it out loud. But the way I'm reading out loud is the way I try to read it in my head, basically. Is if that makes sense. So let's try to do this. Okay. And one thing I would sometimes do is scroll down and look at like the title sometimes. Usually it doesn't help, but for me, it just makes me feel like I'm reading something that makes sense, I guess. And in this case, the title is Bright-Sided. That doesn't tell me anything. Sometimes it tells you something, it's not particularly helpful, but it's just something. All right. Americans are a positive people. This is their reputation as well as their self-image. In the well-worn stereotype, they are upbeat, cheerful, and optimistic. Who would be churlish enough to challenge these happy features of the American personality? Right here, I'm going to highlight churlish. The reason I'm going to highlight churlish is what I like to highlight is things that give me little clues as to the author's feelings and disposition, right? We had talked about this before. I pretend that I'm like a profiler, right? I pretend like I'm profiling the author and trying to figure out who his identity is, right? And you might see like, on like classic detective shows or whatever, like if the suspect speaks a certain way about something, like it gives them away. Like if he says, I don't know, like just making up an example, like if he gets particularly annoyed when somebody's talking about his wife because like, he killed his wife or something like that, that's like an exaggerated thing. But basically what I'm saying is he chose the word churlish here, right? If you don't know what churlish means, it's like very like, just terrible, like somebody who's churlish is like terrible attitude, very like, not not nice in a simple sense, right? So he's calling them churlish, right? He's saying they're awful, right? So things, the way that the author characterizes things is extremely important for understanding what does he believe, right? Because if he thinks that this is churlish, then he believes the opposite. You know what I mean? So who would be churlish enough to challenge these happy features of the American personality? If he thinks that people who challenge these happy features are churlish, then therefore he does not challenge the happy features. Does that make sense? That's why I highlight churlish. I highlight anything, any like particular, like any like very interesting word choice, any flowery word choice, because it helps you understand, oh, the author feels this way, the author feels that way. So okay, so who would be churlish enough to challenge these happy features of the American personality? Take the business of positive affect, which refers to the mood they display to others through their smiles, their greetings, their professions of confidence and optimism. Scientists have found that the mere act of smiling can generate positive feelings within us, at least if the smile is not forced. In addition, recent studies show that happy feelings flit easily through social networks, so that one person's good fortune can brighten the day, even for only distantly connected others. Furthermore, psychologists agree that positive feelings can actually lengthen our lives and improve our health. People who report having positive feelings are more likely to participate in a rich social life. And social connectedness turns out to be an important defense against depression, which is a known risk factor for many physical illnesses. He just like blathered on about like smiling and like how the positive benefits of it. From that passage, I don't actually get anything about how he feels other than like, oh, you shouldn't challenge those features. Look at all the benefits, right? But I don't get much about like how he personally thinks about this stuff. Let's keep going. It is a sign of progress then that economists have begun to show an interest in using happiness rather than just the gross national product as a measure of economy success. The fact that he said it is a sign of progress means that he's giving his approval to this, right? He's approving that, oh, people are taking more of an interest in happiness. That's good. That's a sign of progress. Next thing, happiness is, of course, a slippery thing to measure or define. Philosophers have debated what it is for centuries, and even if they were to define it as simply a greater frequency of positive feelings than negative ones, when they ask people if they are happy, they are asking them to arrive at some sort of average over many moods and moments. So here, he expresses a little bit of doubt, right? He expresses like, happiness is difficult to explain. Like at this point, there's like a little bit of a turn. Throughout here, he's been talking about like, oh, happiness is great. Everybody's happy, right? But here he says, well, what is happiness, right? There's a bit of a turn in what the passage is talking about. Surprisingly, when psychologists measure the relative, surprisingly is again a one to hit. If it's surprisingly or however or strangely, blah, 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 that's one to hit because it's saying like, oh, he was surprised by this. It was something that he wasn't expecting. So it tells you about what he would expect. Surprisingly, when psychologists measure the relative happiness of nations, they routinely find that Americans are not, even in prosperous times and despite their vaunted positivity, very happy at all. So what is he saying here? This is like actually a deep cut into what he's saying. Surprisingly, like I was surprised to find out that when psychologists measure the relative happiness of nations, Americans are not very happy at all, even though they seem to be happy all the time. Do you guys get that from the sentence? Okay, good. So this is a turn. Many passages will do this, right? Where they first set up stuff, and then halfway through they turn. They kind of they veer off into a different direction, and they start talking about something sort of related but a little bit different. And this tends to be where the meat of the passage actually is. What the meat, not the passage, the meat of the author's opinions and author's ideas tend to be in this turn. So, a recent meta-analysis of over 100 studies of self-reported happiness worldwide found Americans ranking only 23rd. Americans account for 2/3 of the global market for antidepressants, which happen also to be the most commonly prescribed drugs in the United States. How can Americans be so surpassingly positive, like wow, above and beyond positive, in self-image and stereotype without being the world's happiest and best off people? The answer is that positivity is not so much their condition as it is part of their ideology, the way they explain the world and think they ought to function within it. Here, the author is straight up telling us his belief, his answer to this question. That ideology is positive thinking, by which they usually mean two things. One is the generic content of positive thinking, that is, the positive thought itself, which can be summarized as, things are pretty good right now, at least if you're willing to see the silver linings, make lemonade out of lemons, etc., and things are going to get a whole lot better. The second thing they mean by positive thinking is this practice of trying to think in a positive way. There is, they are told, a practical reason for undertaking this effort. Positive thinking supposedly, look at this, this is a big hint, right? If you say, supposedly he'll come show up at work, right? That means you don't like really mean it, right? Like you're like, supposedly the doctor will, get my prescription on time, right? If you're supposing something, you don't have full confidence in it, right? So this gives us a hint into his insight. Whatever he's talking about, he's like, supposedly. Like, I'm not advocating for this, but this is what they think, right? Positive thinking supposedly not only makes us feel optimistic, but actually makes happy outcomes more likely. How can the mere process of thinking do this? Look, he said supposedly, and then right after that, he directly expressed doubt, right? You see, so these hints, these word choices are very important. In the rational explanation that many psychologists would offer today, optimism improves health, personal efficacy, confidence, and resilience, making it easier for us to accomplish our goals. You have to go, okay, no worries, it's going to be recorded. Okay, no problem, bye-bye. In the rational explanation that many psychologists would offer today, optimism improves health, personal efficacy, confidence, and resilience, making it easier for us to accomplish our goals. A far less rational theory also runs rampant in American ideology. The idea that our thoughts can, in some mysterious way, directly affect the physical world. Negative thoughts somehow produce negative outcomes, while positive thoughts realize themselves in the form of health, prosperity, and success. For both rational and mystical reasons, then, the effort of positive thinking is said to be well worth our time and attention. All right, so all of that down. Now we do, the first part of our CARS practice, and that is basically we need to put an idea of how does the author feel about what he's talking about, right? So what is the guy talking about? The what is the what? What is this passage talking about, and how does he feel? So, Andrew, what was he talking about? Being happy. Yes, he was talking about being happy. He's talking about people who are happy, being happy. And how does he feel about, happiness or the people that are being happy?
So I would say that he's super partial towards America,
Mm-hmm.
and I want to say he feels like the American way is the right way, and although the world doesn't see America as happy, he feels like America is kind of the standard. So
Yeah, so he is talking about like happiness, and then he expresses like a little bit of doubt about like, how does happiness actually, what is happiness actually like? How do we measure it, right? And then, oh my god, I did it again. Please stop. I just want to move this over here. Okay, so and then in this last paragraph, right, he starts, in these last two paragraphs, he starts exploring like, how are Americans so positive if they're not actually happy, right? And it's like he transitions into talking about like positive thinking. Americans are positive thinking. And then at the end he says, the effort of positive thinking is said to be well worth our time and attention, right? So he himself didn't endorse it, but he said it's said to be well worth our time and attention. So right now we do see that he is like partial to Americans. He said like, hey, like, don't be churlish to Americans, but it's a little bit tricky about like, what is he talking about? Is he talking about their happiness or their attitude, right? So I will say partial to. Oh, I can't. Why can I never edit this?
yeah, it's super hard to edit, honestly.
I can't. I'm not allowed to actually edit
Yeah.
the box after I leave it, right? That's annoying.
Yeah, I think so.
Partial to American happiness or positive thinking. We'll just leave it like that for now. And
Oh,
so,
that was pretty good.
what's up?
That was pretty good.
Yeah, good. So let's look at our first question. According to the passage, positive feelings are A, universal, B, hereditary, C, contagious, or D, ephemeral. So as always, what I do here is not start by looking for the right answers, but look for things to eliminate so we don't have to think about them, right? So positive feelings, right? Positive feelings. What does he say about, well, what does he not say about positive feelings? Is there anything here that jumps out to you as like, oh, I don't think that was really talked about?
Yeah, so I'm gonna just go ahead and say I don't know what D means.
Okay,
So but to be honest, it's kind of my top contender right now. But I want to eliminate A
want to
because
eliminate A? Okay.
yeah, because she's super partial towards America. So I want to take that out of the equation.
All right, I like that.
Um, hereditary. I mean, that's like genetic, like passing out in the family. So
Right.
maybe because of like America, but I don't really feel so. Contagious. I don't see anything about passing things around. So I want to eliminate the contagious as well.
All right.
I could be wrong. Yeah, I want to just take a leap and say it's D because I don't know what the E is, but he sounds kind of interesting. Like I don't know who says churlish, so he
Mhm.
seems like he would use a word like that. So I want to just
Oh,
go with
okay,
D.
okay. I like that. I like that line. I like that line of logic because he used like flowery words, right? So
Yeah.
so that's I mean that's not a bad line of logic. I will tell you that ephemeral means short lasting. So ephemeral is like,
Oh.
yeah, ephemeral means like almost like ghostly, like they're in a flash. So in this case, do you think ephemeral lines up with how he felt about positive feelings and positive thinking?
Damn, I don't think so.
Okay, so let's cut ephemeral. Now, hereditary, we had talked, you had said like it seems, but the thing is, he didn't really talk about family, right? So let's look again and look at like what does he talk about positive feelings, right? Take the business of positive affect, which refers to the mood they display to others through their smiles, their greetings, their professions of confidence and optimism. Scientists have found that the mere act of smiling can generate positive feelings within us, at least if the smile is not forced. In addition, recent studies show that happy feelings flit easily through social networks, so that one person's good fortune can brighten the day, even for only distantly connected others. Furthermore, psychologists agree that positive feelings can actually lengthen our lives and improve our health. Does anything here
Yeah.
link to here?
Now that I see it again, the social network
Mhm.
sounds contagious.
Exactly. Sounds
Yeah.
contagious. And then this is
Yeah, there
correct.
we
Yeah.
go.
So we had seen the passage does not describe positive feelings as being universal, which is correct. You accurately, because he was talking about positive feelings uniquely American, right? B,
Mhm,
he doesn't say it's hereditary because it's like he doesn't mention families, right? And Americans are not families, right?
mhm.
Ephemeral, the passage does not describe positive feelings as being ephemeral because he just didn't say anything about them being short-lived, but you didn't know what ephemeral meant, which was fine. Like sometimes so that thing, that choice of like picking a choice that you don't know, the only time that I would recommend that is if you conclusively eliminated all other choices.
I see. That
Mhm.
makes sense.
Yeah, because if you're like, that's basically like that's what we call an educated guess. Like you cannot confirm the answer, but you can confirm the others are wrong, right? So that's essentially how we would do that. And so the thing here is that like you missed the first part, right? Like in the first time you
Yeah.
didn't think about like, oh, there wasn't really anything mentioned about contagiousness, so we can move, so I can eliminate that, right? What you want to do is like take a look at like at least when they're saying according to the passage, right? Positive feelings are. So you want to take a glance at the passage and see like, can I find anything that rules this out or confirms this or not, right? Because sometimes it can be like just a sentence or two that links that. It doesn't have to be the author saying the whole time like, dude, feelings are the most contagious thing ever. Americans have them, everybody else has it. It doesn't have to be that. It can be like, just tossed in there. So you do want to take take a quick skim and try to figure out if it was mentioned or not. And it's usually like easy to find when it's a choice like this, basically. Any questions? Any questions about this one?
Yeah, I mean, I just have I guess a comment kind of
Mhm.
like, yeah, it's really interesting that it was contagious and you kind of find in the beginning because I thought positive feelings, we didn't get into a positive feelings till like about halfway. So I only associated things with positive feelings from the
Mm.
middle down.
So here we talk about positive thinking, right?
Oh, copy.
And here we talk about positive affect, which refers to the mood,
Yeah.
aka feelings. So they will never play it straight. If it says positive feelings, the word positive feelings are not in this passage at all. If you actually look through it, the word positive feelings is not here because they want you, they don't want to make it easy for you to like hone in on where you're looking at. But you would be able to find something similar that links you to what you're looking at. So here he's talking about positive thinking, which was different than like the positive feelings, because this positive thinking he's saying like it must be different from happiness, right? He's saying how are they positive, but they're not the world's happiest people, right? So he made
Right.
he made a distinction between the two, but over here he hadn't made that distinction yet, and he was just talking about smiles, confidence, etc.
I see.
Yeah. So that's a good point on. Well, actually, right here is positive feelings. So actually, you could find it. Okay,
Yeah, and
so they
that
did.
was right after the
Okay,
social networking
yeah,
too.
right after social network. So they actually, in this case, they made your life a little bit easy.
Yeah.
So you could have gone digging for the word positive feelings, but overall, you would know it was somewhere here because they were talking about the positive affect. And affect, you might know from studying psych soc because it comes up with schizophrenia, I think. There's something called a positive affect and a negative affect. An affect is like your face, like your your expression. So people with schizophrenia can't show like they have a defect in their affect, like they can't express properly their face or whatever. That's something you'll pick up later, like just the word
Mhm.
affect. Okay, good. So far so good?
Yep.
All right, let's move on to the next one. Here we are. Okay. All right. Do you hate it when you see these
Yeah.
Yeah, they are the way I think of them is they're actually a little bit easier because in essence you have a 3 choice rather than a 4 choice. So when I thought of it that way, I was like, oh, that's okay. Okay. I don't like them, but at least I can feel like, oh, okay, it's just 3 things to choose rather than 4 things in a way. I don't know. Maybe I'm just like tricking my brain or something. But basically,
Mhm.
suppose that economists do start using happiness instead of the gross national product as a measure of an economy's success. Information presented in the passage would predict which of the following. Number 1, the transition will be fraught with difficulty. Number 2, the gross national product of the United States will appear to decrease. Number 3, the economy of the United States will be seen as relatively less successful than today's. So what do we see here? We see so I do take a quick look at the answer choices just to know like which one, like falsifying which one will help me the most in a sense, right? So sometimes like 3 is only in like one of the answer choices, so I don't focus on 3 first. You know what I mean?
Mhm.
So 1 is in both, 2 is in both, and 3 is in both of these. So in this case, it actually doesn't help. In this case, like almost all of them are like equally important. So we'll just look through. And so he's talking about suppose that economists do start using happiness instead of the gross national product, right? So which paragraph should we go to look at this?
That was, I think the second one, a sign of.
Yeah,
Yeah,
the
yeah,
sign
the
of
second.
progress, right? So he said the transition will be fraught with difficulty. So let's read this and think about will this be true or will this be false according to him? It is a sign of progress then that that economists have begun to show an interest in using happiness rather than just a gross national product as a measure of an economy's success. Happiness is, of course, a slippery thing to measure or define. Philosophers have debated what it is for centuries, and even if they were to define it as simply a greater frequency of positive feelings than negative ones, when they ask people if they are happy, they are asking them to arrive at some sort of average over many moods and moments. So right now, from this passage, is he like confident in the idea of measuring happiness? Measuring happiness as a measure of an economy's success.
I think he feels like it's questionable.
Exactly, right? He says it's very slippery. People debate it, and even if people answer one way, it's just like, it's just an average. So do you think he would be more likely or less likely to agree with one?
I don't know.
So the transition will be fraught with difficulty. He's saying this transition from gross national product to happiness. What are we measuring? So gross national product is just like, the money, the profit that the country made or whatever. And happiness is like this weird thing that we don't know about, right? If we switched from measuring money to happiness, would it be easy or would it be difficult? According to this, if you just look at this paragraph, do you think he thinks it's easy to measure happiness or is it difficult to measure happiness?
I think he would say it's difficult.
I think he would say it's difficult, yes. So right now, let's lean on the yes side for one. Because he's saying it's slippery, right? And the thing is, he doesn't counter this, right? He doesn't immediately follow up this with saying, however, it's actually very easy to measure happiness if you do this, right? He does talk about, like he's saying, when psychologists measure the relative happiness of nations, right? They relatively measured happiness, but he doesn't comment about how easy it was or whether it was less difficult, right? He simply just talked about, oh man, that's kind of difficult. And even if they were to define it simply, it's still asking people to arrive at some sort of average over many moods and moments. He's saying so this is implying that he doesn't think that this is like a good measurement because you're just averaging things. So for now, let's think that one is on the good side. 2, the gross national product of the United States will appear to decrease. So we have to look at what does he think about the gross national product of the United States. So again, let's look at these paragraphs. And now I want you to look for something here.
So I'm gonna be honest, I eliminated this one not because of reading the paragraph, but because of the question itself. Because it doesn't make sense to me logically from reading the question.
Suppose that economists do start using happiness instead of the gross national product as a measure of economic success, information, and you're saying that it doesn't make sense logically. Why?
Because it's like it just doesn't make sense because they're saying that they're using happiness instead. So if they're saying that
oh, okay, I see what you're saying.
Yeah,
they wouldn't be using that anyway, so it wouldn't.
Yeah, it doesn't make sense to me.
It doesn't make sense. Okay, I see where you're coming from because it's not, they're not using the gross national product anymore.
Yeah,
they're using happiness. So the gross, if it doesn't exist anymore, then how could it decrease? Is that kind of what you're saying?
Yeah, like I don't understand who it would be confusing if that's the standard that would be happening.
Who it would be confusing?
Oh, like who it would appear to decrease to.
Oh, who it would appear to decrease to if we switched. Interesting. I didn't even think of it that way, but it kind of makes sense what you're saying because they wouldn't be measuring it that way anymore. So then it couldn't decrease. I guess if they just stopped, then I guess that makes sense. So I guess, yeah, I think that's a good reason to it wouldn't decrease, it would just stop, right? That's basically what you're saying.
Yeah, because in the question they're looking for economy success, and they're just
Yes.
changing the metrics. So I don't see why the gross national product shouldn't be in the equation anymore in my
Okay.
mind.
Okay, that actually makes sense to me. No, I think that's good. So we can eliminate D. Sorry, we can eliminate 2 based on the fact that we are not actually talking about the gross national product, right? That's essentially what it
Yeah.
is. We're talking about this happiness economy. Okay, good. 3, the economy.
Three,
Yeah, go ahead.
I want to say this is a definite yes,
Mhm.
because in the passage they did make it really clear that quote unquote surprisingly America is not doing well.
Surprisingly, when psychologists measure the relative happiness of nations, they routinely find that Americans are not, even in prosperous times and despite their vaunted positivity, very happy at all. Yes. So you're saying because Americans are not actually very happy, then the economy of the United States will be seen as relatively less successful than today's, right?
Yeah.
So you're leaning towards 1 and 3, right?
Oh wait, hold up. I just realized. Wait,
What?
when it says economy, does it mean success? The success equal economy? I don't know now. I don't know.
So the question was asking about
Oh, okay, economy success.
the
Yeah, yeah,
economy
yeah, yeah, yeah.
success, right?
Yeah, I'm leaning towards. Yeah, 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 yeah. 1 and 3, I'm leaning towards.
Okay, 1 and 3. Um, okay. Do you want to check it?
Yeah, 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 yeah.
All
Let's
right,
go for it. Spin the wheel. Yeah, one and
spin the
three.
wheel. So
It was A.
it was A. And I'm gonna explain to you why. Because this is another trap. Okay? So here's what it is. The economy of the United States will be seen as relatively less successful than today's. Andrew, where did they talk about what today's economy is like?
Oh, never.
Never. You just assumed like, oh, the United States economy is pretty good usually, right?
Yeah.
Yeah. And that's ultimately what they mean by critical thinking. Like you have to like disassociate your assumptions and your knowledge and only go like imagine like you were trapped in a room for like since birth and like this passage is the only information that you have of like the outside world. That's that's essentially like how you have to like process these questions. So and look again, remember when we did cars for the first time and
Mhm.
everybody answered like one answer choice but it was the other one,
Yeah.
and it was because of one word at the end, right?
Mhm.
So this is the same thing here. The economy of the United States will be seen as relatively less successful. Up until that point, that makes sense because of what you brought up. Because they want you to do this, right? They know what they're doing. They know how to like lead you to the answer that seems correct, right? But then at the end, they trick you. At the end, they say then today's. And then you basically, if you choose an answer choice, every element of that choice needs to be supported by something in the passage. That's kind of how it is. So the
That makes
relatively less successful part is absolutely supported, and you chose the correct support for that. Absolutely, 100%. Unfortunately, then today's is a baseless in the context of this passage is completely baseless because he never
Mhm.
talked about what the economy today is like, either in happiness or in GDP or whatever.
True, that's true.
Yeah, and this is this is probably the hardest part of cars for me. Just like learning to really pay attention and not jump ahead and like doubt everything. Like again, like think about again like the idea of like this is a criminal helps me a lot because I think of them as a liar. You know what I mean? I think
Mhm.
I'm more inclined to doubt them, and it puts me more in like a doubtful state of mind, and I'm like, oh, today's? What did you say about today? Like that's how it makes me feel. I don't know if that'll help, but I'm just saying, yeah,
Yeah, it definitely helps. Yeah.
okay. So yeah, so this is a trap, but the more traps you fall for, the more wary you become, right? What's that famous saying? Fool me once,
Yeah,
I'm not. Yeah,
yeah. It's for me once, it's shame on you,
yeah,
and for me twice, shame on somebody else.
yeah. I like that one, but also, have you seen the one where George Bush says it, but he butchers it
Yeah,
completely?
yeah.
That's
That was pretty funny.
that's my favorite
Yeah,
version of it. Fool me once. He what I don't even remember what he said. Fool me once, shame on me. Fool me twice. You can't fool me again, or something like that. Something
yeah,
something really
yeah,
dumb, and I just like that so much. So
yeah.
yeah,
That's pretty funny.
don't let him fool you again. Basically,
Facts, yeah. Most deaf after that, like that
yeah.
was wild. Like I feel like that was a little unfair, but
Yeah, it's like a plot twist, right? Like I don't know where they hit you
yeah.
with the because you were confident in the answer because you
I
had
was
the
very
support.
confident.
Yeah,
Yeah, very
absolutely.
confident.
Yeah. And yeah, like the more you go through this, the more careful you'll become, the more diligent you'll become with you know, giving your full support to an answer choice. But of course,
Yeah,
it can go the opposite way and you can become like, oh shit, I don't know. Oh fuck, I can't figure out between all of these, like what is the correct answer, right? And
yeah.
in that case, you just have to reassure yourself that like one of these is the answer and there is support in the passage. I just need to find it. And that also that like just telling yourself that like it also helps like if you're taking the test and realize like the people next to me answered this question. I can do it too.
That's true.
For some people that for some reason that helped me a lot. When I felt like, oh my God, this is like overwhelming, I was like, the people next literally the whole room is doing it. I can probably do it. you know? I was for some reason that helped me. Okay. All right. I sorry, I felt like I had to give you a pep talk after that one because I felt like
Nah, I appreciate it. Nah,
yeah,
because that was wild.
yeah, that's a
Uh,
tough one, but I, I,
yeah,
it sucks, but it is what it is. Yeah,
yeah, it was a little unfair the way that was done to me, to be honest.
yeah, you got cooked a little bit there,
Yeah.
unfortunately. What did I wanted to see what they said. 3. The hypothetical suggestion to use happiness instead of GNP as a measure of the economy makes no prediction for what might happen to the GNP. Statement 2. No, what about statement 3? What does it say about statement 3? There is no explicit mention of the US economy being successful when evaluating the GNP. Since this is not explicitly a part of the passage, there is no basis for the comparison made in statement 3. It is what it is.
That's wild.
Yeah. All right.
That was a good session, though. That was
That was
good.
good. Yeah. Hey, we're not done yet. One more.
Oh yeah, I'm down. I'm down.
Okay. One last one. Actually, this is the last question. After that, that will be that. But it's good, right? To do practice problems.
It
It's very
is.
helpful. Yeah, it's very helpful,
Very, very
especially if you
helpful.
have. I did this a lot when I was studying. Like I would ask people, like, can you go through this passage with me? And then I would learn a lot from like how they would think. And then I
Oh,
just
that's a
like
good idea.
molded. I just like copied their brain patterns basically, and just did that.
I like that.
Okay,
That's a good idea.
yeah. So okay, yeah. Let's do this. Let's do this one. You want to take a moment and read through it?
Yeah, what's the best represents the artist's explanation of why Americans can so surprisingly have a positive self-image and stereotype about being the world's happiest and best of people.
Mm-hmm.
All right, let's see. America's positivity is not true reflection of their affect. I don't think he will say that. Being well off is not the same as being happy. Let me keep on reading. Stereotypes tend to be unwarranted generalizations. I don't know. Americans tend to have high rates of depression. Whoa, this one is tough.
Mm.
Wait. Stereotypes tend to be unwarranted generalizations. Being well off is being happy.
So when they give you a direct quote like this, right? It's best to like go over there and look at like what the hell was he talking about then, right? So explanation for why Americans can be so surpassingly positive, right? So where did we see that? Surpassingly positive.
That was I think the third paragraph.
1, 2, 3. It
Fourth.
was the fourth paragraph. Yeah. So let's take a look at this and let's understand why did he say that, right? How can Americans be so surpassingly positive in self-image and stereotype without being the world's happiest and best off people? This was a question, right? And then he has an explanation. The answer is that positivity is not so much their condition as it is part of their ideology, the way they explain the world and think it ought to function within it. So, positivity is not so much their condition as it is part of their ideology. Which of these answer choices seems to match what he's saying here? Positivity is not so much their condition as it is part of their ideology.
That's crazy because that's the one that I crossed out, which would be A. And it's funny because like the rest don't even really make too much sense. Like Americans have D. It's not supported.
It's
I don't
not.
think so.
Well, I think he had said something about like they get the most antidepressant.
Oh, did he talk about that?
He talked about that right here, but that doesn't necessarily mean that Americans tend to have high rates of depression, right? It's not exactly the same thing. That's just like an implication. But again, your logic was on the right track. You were like, oh, A seems to match this the most, right? Their positivity is not so much their condition, aka their affect, right, as it is part of their ideology. So their positivity is not a true reflection of their affect. And remember what this whole passage was about. At first he said like, oh, they're super happy, right? And then he said like, surprisingly, they're not actually happy. So then why do they appear to be happy? Why are they so positive, right? And then he talks about they just have positive thinking. You know, they practice trying to think in a positive way. So it's not their positivity is not a true reflection of their happiness, right? It's just how they want to portray themselves. And we look at the other ones. Being well off is not the same thing as being happy. Does he ever talk about being well off or prosperity?
It doesn't even make sense.
It doesn't even make sense. Exactly. If it doesn't make sense, you get rid of it. Stereotypes tend to be unwarranted generalizations.
I feel like that's counterproductive towards what he's saying about Americans.
Absolutely. It's totally the opposite, right? He's stereotyping all Americans, is he not?
Yeah.
So this is bogus. This is the opposite of what he's saying. And that's why it's so important to like get a good idea of what he feels, right? And we had written before, like he thinks all Americans are happy or positive, right? So good. And so then this one is Americans tend to have high rates of depression, but again, this is like sort of
the question.
Exactly. You took the words right out of my mouth. It's sort of supported, but it's not answering the question.
Yeah.
Excellent work. This is exactly how you answer this question.
That's funny because that first one I was like, nah, the answer weak, and that was reading the rest. I was like,
right,
that one not looking so bad anymore.
Yeah, exactly. Like that's when they give you a quote, like just write it down somewhere. Like if they give you a quote, go read it because they want you to read it. If they give you a quote, yeah. So and and then that immediately cleared up your decision about like what could be the answer or not. Yeah, good, great job.
That's crazy. Nah, I appreciate it. It was a great session.
Awesome. That was my hope to help people clear up like their approach. I think right now you have to work on your approach to like solving stuff. Like I've taught you, like if you notice the past couple of sessions, I taught you guys how to study, right? Like I taught you how to learn and how to memorize and how to keep everything. Now I'm teaching you guys how to do the test itself, right? Like the studying part, that's in your hands now. I can't teach you anything else, and I can't put the stuff in your brain, right? Like you just have to go study for yourself. But I can teach you how to tackle passages and stuff, and like, yeah, just how to. I said what I wanted to say. That's what I'm saying.
Yeah, no, I appreciate it. Yeah. No, it's good. It's good.
Good. I'm glad you're benefiting. Okay.
Yeah.
So that's it for today. Next week, oh man, this is so much slower than I mean, it's not a bad thing. I'm not complaining about it. I
Yeah,
was
no,
just
I'm not
thinking,
complaining about it either.
yeah, I was just thinking like, oh, I thought like 30 minutes per passage, but no, it's actually more like an hour per passage, which is good. Like we're digging into
Mhm.
like, the nuts and bolts of how to get through the questions. But yeah, good.
Yeah.
I think next week we'll do a bio and we'll do a psychology, sociology, and we'll just keep looping like that, and we're gonna get better and better.
Sounds good to me.
All
Hope you
right.
have a great week.
I will. I
Great
have to
week.
get some work done, but after that, I'll have a great week. And I hope
Awesome.
you have a chill week too.
Yeah, it's gonna be a little crazy. I ain't gonna lie to you. But, yeah.
Okay.